Naples sits atop a restless caldera. New machine learning has uncovered tens of thousands of microquakes missed before. Mapped in 3D, they outline a circular pattern beneath Pozzuoli, consistent with ancient ring fault structures. With ongoing uplift measured by GPS and satellite radar, a shallow M5 is plausible. Here is what the data say, and what matters for people living on the ring. Just west of Naples lies Campi Flegrei, a wide volcanic field spread across land and sea. It is a caldera, a bowl formed when the ground collapsed after a giant eruption roughly 39000 years ago. Towns like Pozzuoli sit right on top of it. Under the surface runs a maze of fractures filled with hot fluids and gases. Pressure here rises and falls in pulses known as bradyseism. That slow lift and sink is not theory, it is measured. In the 80s, the ground rose by meters and parts of Pozzuoli were evacuated. No eruption followed, but the disruption was real and long-lasting. Today, Italy's observatories track the same signals in detail. Seismometers record swarms. GPS stations and satellite radar measure uplift down to the millimeter. Gas sensors watch changes in sulfur dioxide and carbon dioxide. Thermal cameras follow heat at the surface. This is a living system, and every instrument tells the same story. The caldera is under stress. All of this sits under a dense urban area. Protezione Civile defines a red zone that includes several municipalities. Preparedness here is not optional. It is survival planning. Scientists reprocessed millions of seismic waveforms with machine learning, letting algorithms listen for tiny signals that standard methods miss. The updated catalog for 2022 to 2025 jumped from about 12000 detected events to well over 50000. With that density, swarms that once looked like static resolved into clear patterns. During active phases, INGV bulletins and satellite analyses report uplift of centimeters per month, confirming that deformation is ongoing. Plotted in 3 die, the detections trace a thin, circular belt beneath the caldera, consistent with ancient ring fault structures and with the zone that is currently uplifting. The same analysis highlights 2 through-going lineaments converging beneath Pozzuoli and shows that recent seismicity clusters more to the north than earlier catalogs suggested. Most events lie within the upper few kilometers of crust, a hallmark of bradyseism-driven stress and fluid pressure changes, rather than magma rising toward the surface. This matters because better catalogs give better geometry, and better geometry turns hidden structures into targets for risk reduction. Linked with GPS and satellite radar, near real-time AI catalogs let scientists watch stress migrate around the ring and see when swarms tighten on a specific arc while uplift persists. In that configuration, a shallow magnitude 5 slip on the loaded arc is a credible scenario even without clear magmatic ascent. The takeaway is operational. The ring behaves as an active boundary inside a densely populated caldera. Thousands of tiny slips sketch the weak links and indicate where a stronger release is more likely. Recent sequences confirm the pattern, with moderate shocks followed by dense swarms and reports of cracked masonry and damaged facades, especially in older buildings. None of this implies an imminent eruption. It indicates a stressed, brittle lid where Protezione Civile benefits from the clearest possible up-to-date picture of how and where stress is shifting. A slipping ring fault can deliver a damaging earthquake even if magma never rises. At Campi Flegrei, most recent quakes are shallow. They are driven by pressure and hot fluids in fractured rock. Shallow sources mean shaking can hit with little warning. That is the blunt reality of a caldera under load. History already proved how disruptive this can be without an eruption. From 1982 to 1984, Pozzuoli lifted on the order of 2 meters. Thousands of quakes rattled the city. Streets cracked. Buildings were declared unsafe and cordoned off. The Rione Terra district required years of restoration. Tens of thousands were evacuated from the historic center while the ground was still rising. Today, the uplift is smaller but steady. That is a live sign that stress is being stored and transferred into the caldera rim. Crews can seal cracks in streets and walls, but if uplift continues, those cracks often reopen. This is why a magnitude 5 scenario is on the table. The circular structure and linked faults are long enough and shallow enough to host an M5 slip. In dense neighborhoods of Pozzuoli and western Naples, that level of shaking can crack masonry, shift chimneys, and interrupt water, gas, and power. We already saw what a smaller event can do. In May 2024, an around M4.5 sequence damaged buildings, closed schools for checks, and sent residents into the streets. A shallow M5 on a ring segment would be a different tier of impact. What we are watching is a structure under sustained load. Machine learning catalogs recover many more tiny quakes than older methods. Those extra detections reveal swarms that trace the circle and show where stress is concentrated, especially to the north where earlier catalogs were sparse. With more signals, the pattern is no longer a guess. It is a map of pressure and fluid movement along the rim. For authorities, this becomes action. Real-time seismic and GPS can flag which arc is loading. If swarms tighten on one segment while uplift persists, the short-term chance of a shallow slip on that arc rises. That guides pre-checks of hospitals, schools, and lifelines and clear public messaging, while the system stays restless. The takeaway is simple. You do not need an eruption for serious impacts at Campi Flegrei. A reactivating ring inside a crowded caldera is enough. The 80s proved it, and today's uplift and expanded quake catalogs underline it again. Damage is possible without an eruption. A shallow M5 on a reactivating ring fault segment can crack masonry, shear brittle pipe joints, and knock lifelines offline. In dense areas like Pozzuoli and western Naples, near-surface shaking can tip parapets and chimneys, spall brick, and scatter debris on narrow streets where many buildings were not strengthened for lateral loads. Transportation and utilities feel it first. Differential uplift along the ring can split asphalt and heave bridge approaches, slowing emergency access and forcing detours. Water and gas lines can part at weak joints, causing local outages and occasional leaks. Power cabinets and pole lines may sway, and cell sites can saturate. Inspections can pause sections of metro or rail if track geometry shifts. In the port, quay walls and infill may settle unevenly and require rapid engineering checks before traffic resumes. The exposure is large. Roughly 500,000 people live on or immediately around the caldera floor, with many more in the Naples metro commuting through it daily. At this scale, even a moderate, non-eruptive event becomes a Protezione Civile challenge. There are too many lifelines crossing the ring to assume routine operations after a sharp shock. In recent swarms, schools have closed for inspections and residents have reported cracked walls near the strongest clusters, consistent with the vulnerability of older districts to shallow shaking. Put simply, a ring fault M5 would be a near-surface stress release inside one of Europe's most crowded volcanic depressions. Shaking could last tens of seconds near the ring, followed by days of aftershocks. Emergency managers would balance rapid utility repairs, targeted building cordons, and traffic control while watching deformation and seismic data in real time. No magma ascent is required for this scenario, only continued brittle slip where instruments indicate the highest stress. Italy's observatories keep Campi Flegrei under continuous watch. Networks track earthquakes, ground lift, gas, and heat across the caldera. The current volcanic alert level reflects readiness, not an evacuation order. Weekly bulletins summarize swarms, depth, and deformation so authorities can adjust quickly if conditions change. Satellite radar and GPS complement local stations, resolving uplift around the caldera ring where stress is concentrated. Together, these systems provide the clearest, near real-time picture Naples has had. Protezione Civile uses a color-based framework for volcanic emergencies. If seismicity and deformation accelerate and cluster in sensitive sectors like Pozzuoli, authorities can move to higher alert phases, restrict access, and activate traffic, school, and hospital protocols matched to local maps. Plans link surveillance thresholds to actions so city and regional leaders know when to stage transport, open shelters, and secure lifelines. These plans drive drills, signage, and route planning that residents see on the ground. On the science side, researchers correlate uplift with swarm behavior to understand how deformation drives bursts of earthquakes. The tight coupling between ground rise and seismic cascades helps explain why shallow clusters can flare without magmatic ascent. That insight feeds directly into response because it focuses attention on structural shaking risk even when gas and thermal data do not indicate magma approaching the surface. On the science side, researchers correlate uplift with swarm behavior to understand how deformation drives bursts of earthquakes. The tight coupling between ground rise and seismic cascades helps explain why shallow clusters can flare without magmatic ascent. That insight feeds directly into response because it focuses attention on structural shaking risk even when gas and thermal data do not indicate magma approaching the surface. Early warning is being upgraded on two fronts. First, the monitoring grid has been reinforced with additional seismic stations and continuous geodesy, improving coverage of small quakes and subtle ring uplift. Second, machine learning catalogs now extract many more tiny events from the same sensors, revealing hidden fault geometry and faster stress migration around the circle. The practical outcome is faster situational awareness, from pre-positioning repair crews to issuing targeted guidance for neighborhoods on the ring. Right now, there is no clear signal of magma rising toward the surface. The operational concern is structural. A shallow caldera ring earthquake strong enough to damage older buildings and lifelines is the realistic near-term risk. With round-the-clock telemetry, satellite data, and AI-assisted detection, Naples has a time advantage it lacked in past crises. The goal is specific: keep people informed, keep routes open, and be ready to act if the data show stress focusing on a particular arc of the ring. Beneath Naples, data point to an ancient ring fault in the shallow crust taking up stress. There are no clear signs of magma moving toward the surface. What we see is rock under pressure, with dense microquakes and measured uplift. AI and modern geophysics now give a clear view of how stress builds at Campi Flegrei, near real-time maps of uplift and swarms, and a high-resolution catalog that traces the active structures. Knowledge buys time, and time saves lives. The takeaway is simple: serious impacts do not require an eruption. A shallow M5 on the ring could crack roads, break water lines, and strain older buildings around the caldera. Preparation is not panic. It is local, practical, and achievable. Stay informed. Know your zone. Update your go bag. Follow INGV and Protezione Civile updates. Share this with someone in the area, and subscribe for more geo content.